Cool. Okay, so in the last video, we got everything set up for Git, and we made a clone of our repo. So I was using the workshops repo, but you would have made a clone of whatever your project repo is. So go ahead and stay in that project repo in your terminal. So again, if you, so cd dot moves up to the parent, but I made this folder called YML in my computer, in my parent directory. And then I cloned into this YML, and then if I press ls, it shows, okay, this workshops repo that I have right here, its clone, my local clone, exists in this place in my computer, so I'll cd into that, workshops, and then ls, and again, you can see these two files, license and readme, that are in my kind of origin, that's on GitHub, are also now on my local computer. So the next step is, once we have this stuff set up with Git and GitHub, we need a dependency management and kind of like a virtual environment system. So you can read through it in more detail here, but essentially a dependency is a version of a specific software package or some software library that you're using in a code repository. So for example, if you're working on a project, you might have, PyTorch version 1.9, but then if you have a different project later on that needs PyTorch version 1.4, if you're doing both projects on your same computer, if you keep switching back and forth your install versions, you only have one version that works for each project at a time, so you won't be able to switch back and forth easily. So instead of modifying your entire global computer's different settings, whether it's versions of PyTorch or versions of any other software, instead what we do is essentially abstract away and kind of nicely encapsulate for every single project. We'll have a separate virtual environment that has a specific version of Python and all the right versions of your different software libraries and different tools and packages for that one project in one place. So that way, when you need to start working on a project, you can just start up that virtual environment, everything's ready, all the versions are right, and you won't have to worry about dependencies. And this is something that comes up a lot in industry, is that a lot of times you'll get a bunch of bugs and errors just because the versions are mismatching. If someone changes the dependency in a different kind of library that you were using, or a different repository that you were using, you'll have to update your dependencies as well. So keeping track of this stuff is really important. There's a related concept called containers with something called Docker. We'll explore that later on, but for now, we'll focus on using Conda, which is a tool that does a lot of things, but one thing it does really well is create virtual environments and manage these dependencies. So to install Conda, you can go to their site right here. And once you have this, there's a couple options. So I'll go to regular installation. I'm on macOS, so I'll click macOS. If you're on Windows or Linux, you can click that. You can basically install either Miniconda or Anaconda. I think I installed Miniconda on my computer, but you can do either one. If one of them gives you trouble, you can do the other one. Anaconda is actually, I think I did Anaconda on my computer. It's pretty quick to install. It just installs like a regular application, so you can just press the download just like you're installing an app on your computer, same way. So once you have that installed, you should have Conda set up. And if you do have errors, feel free to message me on Slack if something's not installing properly. I'll try to debug it for you or with you, so you can also see what's going on there. But once it does work, you can check and see if it's actually working by typing in Conda list or Conda end list. Okay, yeah, so a bunch of stuff here. So it looks like, my computer Conda was installed properly and it's working. Clear that guy. Cool. So the next thing you'll do is, for your project, you're going to create a virtual environment. So the command to do that is conda create, and then we'll give our virtual environment a name. So the important thing is that you're creating this one virtual environment that you're going to use for your project every single time you work on it. So I usually keep the name of my environment pretty similar to the project name, just like a short version so you can type it really quickly. So workshops is a pretty short title already, so I'll just call it conda create virtual environment named workshops. And then the next thing is to specify what version of Python you're using. I'll go ahead and use 3.7. You could really pick any of the latest versions, but 3.7, 3.8, those are pretty reliable options. So I'll click that, and then you can see it's kind of spinning up and creating everything. It's asking me, we're going to install all this stuff. Is that okay? Proceed. Yes. I'll type Y. And now it's going to go ahead and install all of that. So what it's doing now is just kind of setting up a virtual environment, a brand new one that's clean, and you can install all your stuff in there. for your project. So we'll let this guy finish up. And you can see that here it tells you the commands. Right now we're still in our base environment, which is the kind of global environment that's for your computer. So we've created the workshops environment, or the project environment, but we need to actually activate it. So I'll type in Conda, activate, and then the name of the virtual environment. In my case, it's workshops. You would call it whatever your name that you picked was, and then press that. And now you can see that this guy has changed from base to workshops. So I know now I'm in my workshops environment. And you can actually check also, if you type conda env list, you can see all of the virtual environments that you've set up. So you can see there's a bunch of kind of random ones here, but you have your base one, and then you have your workshops one, or whatever you just called it. So cool. So we know that we got our environment open, and now what we need to do is we can start installing stuff. We can start installing all the different stuff we'll be using for our project. So the first thing that we might do is install PyTorch. So I'm going to actually come back to this requirements.txt part. Let's first install PyTorch. So PyTorch, you can actually install it using Conda, so it's a good thing we got that set up. You can go to PyTorch's website right here, and then go to install. And then we're going to install it locally, so this should most likely be set up already. Like as soon as you log on, it should be the correct thing for your system. If it's not, just make sure you're pressing the correct things. So here, it gives you the command you need to run to install. So here I'm installing a stable build of PyTorch, which is basically something that's been, run through all the checks and it's working. Preview, or the nightly build, is something that releases new features for people to try out, but it could be unstable sometimes, so download the stable build. My OS is Mac, I'm using Conda to install. Pip is another popular one, but we'll stick with Conda. Python, my computer is it's a regular MacBook, so it doesn't have like a GPU like NVIDIA chip or anything, so we can't use CUDA. If you're running it on like one of Yale's servers for like Tanger or something, then it'll have CUDA available for you, but for now we'll just, our projects won't be too crazy yet, so we will just install it as is. So I will paste that guy in there, and then now what it's doing is it's installing PyTorch into, and again it's asking, do you want to proceed? Yes. But it's installing PyTorch into this virtual environment. So that way later on, if I do have a different project and I have a different version of PyTorch, or if I have different kind of like things I need to use, different libraries I need to use, I can have a different virtual environment for that. So I don't need to worry about versions conflicting and things like that. So I will let this guy download. And while that's downloading, the next thing to keep in mind is we need to know, especially when you're working on a project with multiple people, you'll have, you want to have all your dependencies, all your requirements to be the same versions. So for example, if you and your team are working on your project, you want to make sure that you all have the same versions of everything, so that way you can all have the same virtual environment that works for everyone. So again, this virtual environment workshops is existing on my machine, but if someone else wanted to come in and also work on this repo, they would want to build their own virtual environment that uses all the same settings that I've already had, all the same requirements. So one thing to do there, if you want to have some kind of log of all the versions of the software I'm using, you can build a requirements.txt file. And this will basically just store a list of all the different dependencies that you'll have in your project. And it's actually very easy to create this. There's two options. You can either do pip freeze to get basically all of the dependencies that you currently have in your project, and this file will redirect the output into this requirements.txt file. So we'll make this file and put all this stuff in there. So I'm going to go ahead and do that. I'm going to do pip freeze requirements.txt. Press enter, let it do its thing. And then basically what this is doing is it's going through every package I've just installed on my virtual environment workshops, and it's freezing them. It's getting a snapshot of what all those version numbers are, and it's saving them into this file requirements.txt. So if I do ls, you can see now I have this new file, requirements.txt, and if I do cat requirements.txt, it basically just print out what's inside that file. It shows here's all of the versions of the things I have. And you can see it has some extra stuff in here, but you don't need to worry too much about that. Now you know that, okay, I have this file that contains all the versions. So I have this thing called certifi. I have version 2021.10.8. If for PyTorch, I have version 1.10.0. For Torch Audio, Torch Vision, I have these versions. So the great thing is it automatically finds all those versions and does the work for you. One kind of downside to pip freeze is that it will basically list every single package in your environment, even if you're not using it in like actual code files. So this repo workshops is kind of like a dummy repo. I don't really have any code in here. But later on, if you're installing a bunch of software and you realize that like, okay, I'm only using a couple of these requirements, I'm not actually using everything that I installed, you could use this thing called pip recs or pip requirements. And that way it'll only save dependencies that are being used in imports in your project. If that doesn't make sense to you, don't worry too much about it. You can use pip freeze, and it's fine. Pip recs will it'll basically just only save the things that you're actually using into your requirements file. But you can read about it here. But either way, get that set up and you have this file here. So one thing you might notice is that, okay, we've done all that stuff, but I made this requirements.txt file in my local version of the repository, but it's not here in my GitHub version of the repository. Because again, what we did was when we cloned, this was the origin, this is the repository on GitHub. When we cloned it locally, we got a version of the repository on our local computer, but these changes that we're making to it, like adding this new file, requirements.txt, has not yet been saved to the GitHub in the cloud. It doesn't know that we made this new file. So one thing to do to push your changes back up is that you run the command git push. And there's actually a couple steps you do before that, and I have it all laid out right here. There's 3 steps. Each of these commands does one thing. So the first thing, you do git, actually let's just do git status. Git status tells us what's happening. Git status says, well, we have this new file, requirements.txt, and it's untracked because it's a brand new file. You just made it, so we don't know about it yet. So what do we do to add this file into our Git system so that way it can be kept track of and also be pushed back up to our GitHub cloud version of the repository, our origin? We can use git add dot. You don't want, if you might see some places use git add star, you don't want to do star because star will add everything, even if it's a file you're supposed to ignore. We'll learn about something called git ignores later, but basically just do git add dot. It'll add everything that has been, a new file or changes to files, and then you can check git status again. You don't need to do this part, but you can just check that now. Okay, this new file requirements.txt, we know of it. Git's keeping track of it. So once you do git add dot, then you do git commit -m. So this is saying, okay, I've added this file, now I'm committing this change. I definitely want to make this, so you'll do commit -m for message, and your message I'll just say added requirements.txt. And it's just a short message that says what changes have you made, and good software engineering practices is just something short and sweet, concise, but it covers the change you made. Here I just added a file, and then now it says, okay, we've added that file, and you can see one file has been changed, 12 insertions, we added 12 lines into that file. Cool. And then the last thing you'll do is git push. And this, now you've committed those changes and you've pushed them. This won't pop up, I'm not sure where this guy's coming from. But now you can see you've pushed those changes, and it'll show you, yep, we've pushed this to github.com, Yale Machine Learning, workshops.git, and it's done. So you've pushed that change, and now if we go back to our workshop and refresh it, you can see 35 seconds ago, this new file has been added. So you can click that guy and see, yep, this is the exact same thing that we saw when I catted it out here. So cool, so that means, and you can see who submitted it, well, it was me, so that means that your Git was set up properly because it's your actual account. If it says just your name and it's like a grayed out logo, you might not have set up your SSH or HTTPS properly, or HTTPS you might not have logged in properly, so let me know if you have issues with that. But cool, yeah, and you might, if you do HTTPS, they might ask you to enter your password or a keyword or something, so just do that before it'll let you commit. SSH, it'll automate that for you. But cool, at this point, you're done. You've got everything set up. So you got your IDE, you got VS Code ready, and you can actually open a folder, so you can open this same workshops repo here, and you can browse all your files there. You got your version control set up with Git and GitHub. You got Conda set up for your version or your dependency management for all your different softwares that you're going to be using in a virtual environment. And actually, let's say if you want to, let's say I close out of this terminal and I want to start working on a project again. If I do new window, one thing you can do, you can see that now when I open this up again, I'm back in my base. So if I cd into YML, that folder I made, and then again, if I cd into workshops, you can see I'm in my base environment. So I'll do again Conda environment list just to see, what did I call that? Oh, I called it workshops. So now I'll do Conda activate workshops. And now we're back in our workshops virtual environment, and you can keep working right away. You don't have to, install everything all over again. So that's kind of the great thing about using virtual environments, is that everything's always ready for you. And if you make changes, just remember to update your requirements.txt. You can just every time just do pip freeze into requirements.txt, or use pip rex, whichever one you prefer. But yeah, that's pretty much it. So now you have all of your software tools set up so you can start working on your projects.